Hi everyone, welcome to your favorite learning channel again. So in the previous session, we learned about the fundamentals, the substitution, addition, subtraction, and multiplication and division. Today we will learn about the remaining topics within the topic of algebra, and we'll be learning fractions, expansion of expressions, binomial products, and special binomial products, and how to solve the problems related to these. For any questions that you have on these topics, feel free to put your questions in comments and we will try and answer as many as we can. Okay, so we will start our topic with fractions. How do we add algebraic fractions? Now, algebraic fractions are not very different from mathematical fractions. We'll have to understand how do we deal with them. Now, let's say we have an algebraic fraction x by 3 plus 2 by 7. One of the term is algebraic in nature. We do not know the value, but we have to simplify this, right? So this is the question. The process will be the same. You take an LCM of 3 and 7, right? So 3 times 7 is 21. So you'll take 7 times x, 7 times x, and then 3 times 2, that is 6. That is the answer. The process remains the same for an algebraic fraction when we add, subtract, multiply, or divide them. Right? Let's take another question. We are doing 23 by 3x minus 7 by 3x. How will you do it? If you take an LCM, you take 3x. So this is 3x. You can do a 23 minus 7, which will be equal to 16 by 3x. That would be your answer. Okay. Now, let's say we have another question where we have to find out the value of 4a by 3b, right, minus 2a by 7b. These are algebraic fractions. Now see, a and b are unknown quantities in both terms, but then we have to simplify this. Now if you take an LCM of all this, what will be your LCM? Like a standard, take the LCM of 3 and 7 first. That will be 21, and the LCM of b and b will be b. So that is 21b is your LCM. Now if you divide 21b by 3b, you get 7. So that is the number you will multiply in the numerator, which is a standard arithmetic calculation process. So you do, this is 7. So this becomes 7 times 4 is 28a minus, same process is applied here. So this is 3 times 2 is 6a. So 22a by 21b. That is your answer. Okay, let's take something a bit more complex. X plus 1 by 4 minus x by 3. Right? So this is the question. Sorry, just a moment. Yeah. Okay. So what do we do? Same process. Take an LCM. 12, 4, 3. So you have to multiply this with 3 and this with 4. So you get 3x plus 3 minus 4 by 12, of course, and then you get 3x minus 1 by 12. That is your answer. Okay. So what we have done is we just expanded the brackets like you would do in mathematics, and then we simplify and cancel down whatever we could. Right? Now, if you have to multiply some algebraic fractions, the process still remains the same. Suppose you have m by 2 times 3 by x, and you have to multiply them. Your answer will be 3m by 2x. You multiply the numerator, you multiply the denominators, and they remain the way. Right? If you are able to cancel some common terms, you will do that. So if you have m by 5 times 10 by 3x, because 5 gets cancelled against 10 by 2, you get the value of 2m by 3x. That's after simplification. Right? Now let's take another example. 8a by b times 3b by 5 times 4c by 3a. Right? This is what we have to calculate the value of. Now this is b. I can cancel this b against b. I can cancel this a against a. Right? Can I cancel anything else? This 3 gets cancelled against 3 as well. So I'm left with 32 c by 5. Another example. Let's take one more similar example. So we have 3x square y by 2a times 8a cube by 5xy squared. Okay. Now, either we can cancel whatever we can, or we can first multiply. So let's first multiply. It might become easier. So 3 times 8. We learned about it. Multiply all this numerator. 3 times 8 is 24. X square y and a cube. Whether you write a cube before x square y doesn't make any difference. Right? So we just have to multiply them and put them all together in one expression. That's one number. Then 2 times 5 is 10. A x y square. Right? Now there are some common factors that we can cancel and simplify it further. 24 and 10, they can both be divided by 2. So this will be 12 and this will be 5. Right? So that's done. X square, and there is an x in the denominator, so you are left with x, just x. Y and y square in the denominator, so you are left with y in the denominator. Right? And a cube, and then a in the denominator, so you are left with a cube, and this is a. So these are 3 a's and this is just 1 a, so you're left with a square. That is your answer. Okay. Things might get slightly tricky when you have to divide. So if I have 2x by 3 divided by 2x by 5. Right? Remember, these were multiplications, but this is division. So how do you deal with things like this? Anything that has to be divided, you can simply take the reciprocal and multiply them. This is a very important trick in mathematics, in algebra, that everything that needs to be divided, and if it is a fraction, especially if it's a fraction, it becomes so much easier if you can just reverse the position and multiply them. Right? So this 2x and this 2x gets cancelled. You're left with 5 by 3. That is your answer. This is going to be very, very useful when we have a bit more complex calculations to do. So I'll take one example. Hope you have understood these. Now we will take some more complex examples. 6x squared 5y divided by 3x by 10y squared. Okay. 6x squared 5y. I'm not changing anything here, but the second factor, which is the divider factor, can be multiplied, and you can do 10y squared by 3x. This becomes so simpler. Once we've done this, this becomes remember 6 and 3 can get cancelled, x can get cancelled with x. So you cancel this, you cancel x, you cancel this, you get 2, right? Similarly for y, you get cancel this, and then 5 gets cancelled with 10, gives you 2, right? 2 times 2 gives you 4xy. That's your answer. There is nothing left in the numerator, in the denominator, and you're left with only the numerator. So the rule is just reverse and multiply if you have to divide anything. So what will you do if you have to, let's say, divide 5x square divide by 10? Because 5x square by 3 is 2. Now in this case, although this is not a fraction, this can be written as a fraction. 5x square by 3 divided by, this is 10 by 1. Anything you can take, then anything by 1. So if there is a number which is 5, that can be written as 5 by 1 if you have to write in fractions. 5x square by 3 times 1 by 10. This gets cancelled. You get x square by 6. That is your answer. Okay, so once we've done the multiplication and division, let's take one more example where you have multiplication and division both. 3x square by y multiplied by 2y square by x divided by 7x by 3y. Okay, you have a multiplication and you have a division. The easiest thing to do is the multiplication remains as it is. We do not change it. But for the division, remember the rule, we said reverse and multiply. So we'll multiply, that's multiplication, and we will reverse. So 3y by 7x. Okay, now if you want to multiply all of these, we'll see what we get. So 3 into 2, 6, or we can start cancelling. 3 into 2, 6 into 3, 18, x square and y cube, because there are 3 y's here, divided by 7 x square y. Okay, now x square gets cancelled, y gets cancelled with y's cube, so you're left with 18 by 7 y squared. That is your answer after you've done all the calculations. So these are some examples that I wanted to talk about when we start discussing multiplication and divisions with respect to algebra. Right now.